Welcome to the free response part of the January 2019 Regents. Here's number 25 where it says to solve algebraically, so that's a keyword, for x. So algebraically means that we have to actually do the math and show our work. So in order to get x alone, we should subtract both sides by 3600. And we're going to have 1.02x is less than negative 1600 plus 1.04x. In the next step, we can subtract 1.04x. And when we do that, we will end up with negative 0.02x is less than negative 1600. And in the final step, we can divide both sides by negative 0.02. Now, when you divide by a negative and you're working with inequalities, you have to remember that you must flip the inequality. So now it's x is greater than, and your final answer, x is greater than 80,000. And that's it. 26 says that the number of people who attended a school's last 6 basketball games increased as the team neared the state sectional games. The table below will show the data, and we need to state the type of function that best fits the given data and justify our choice of the function type. So as far as options goes, typically the two types of functions that we have to deal with are either linear, which is a straight line, or exponential, which is a curve. And the two main differences are that in a linear function, you are repeatedly adding or subtracting to get to the next y value, whereas in an exponential, you're repeatedly multiplying or dividing to get to the next y value. So if we look at the x's, which in this case talk about the games, versus the y, which is the attendance, since the games are just increasing by 1 each time, we can focus on the y values. And we need to figure out what is the pattern. So how are we getting from 348 to 435, and then to 522, and so on and so forth. So if we look at this, we can see that we're consistently adding 87 each time to get to the next term. And since we are adding consistently, this must be a linear function. And my explanation would have to state that in linear, you're repeatedly adding. Number 27, we have to solve this quadratic algebraically. So again, we can't just graph it or look at the table. We have to actually do the math. So there are a couple ways we could do this. We could use the quadratic formula. We could factor. We could complete the square. In my opinion, I think factoring is the quickest. And in factoring, what we have to figure out is what are factors of negative 9 that also add to negative 8. And those numbers would be negative 9, positive 1. Which means I'm going to have in one parenthesis x minus 9. In the other parenthesis, I'm going to have x plus 1. And now in order to actually solve this, I need to set each factor equal to 0, and then I will be able to solve for my x's. So when I add 9 to both sides, one of my answers will be x equals 9. And when I subtract 1 from both sides, my other answer is x equals negative 1. Now to explain the first step that you use to solve the given equation, well, since I chose to use factoring, I needed, in order to factor correctly, I found factors of negative 9 that also add to -8. 28. The graph of f of t models the height in feet that a bee is flying above the ground with respect to time it traveled in t seconds. State all the time intervals where the bee's rate of change is 0 feet per second and explain your reasoning. Well, the rate of change, that's talking about your slope, so we need to talk about when is the slope equal to 0. So, all time intervals, well, we have from 2 to 6 would be a 0 slope, as well as from 14 to 15. So, there are ways to write this. I'm going to use inequalities, and I'm going to say when 2 is less than or equal to t, which is less than or equal to 6, as well as 14 is less than or equal to t, which is less than or equal to 15. What that means is that when time is between 2 and 6, and when time is between 14 and 15 seconds. Now, in order to actually explain this, the quickest explanation that I could come up with is that this will have a slope of 0 since all horizontal lines have a 0 slope. Now, if you're wondering how you might know this, the best thing I could come up with is to talk about SlopeMan. So, each of these lines in SlopeMan represent a type of slope, and we've got positive, negative, undefined, and 0. And again, this is the 0 slope. So that's how I know quickly that whenever I see a horizontal line, the slope will be 0. 29, we're going to graph the function f of x equals 2 to the power of x minus 7 on the set of axes below. Now, what I've mentioned before is that it's very helpful if you make a t-table, because if you mess up your graph but you have the correct table, you can still earn partial credit. So, if we type this into our graphing calculator and we look at certain values, let's just look at from -1 to 4. Whoops. -1, 0, 1, 2, 3, 4. So at -1, our y value is -6.5. At 0, we've got -6, -5, -3, 1, and 9. So this is what your graph should look like. Make sure that there are arrows because there are no restrictions, they go on forever. And you want to make sure that you label it. And we can label it f of x because that's what they call it. So that's all we have to do for our graph. Now for the same question, it says, if g of x equals 1.5x minus 3, determine if f of x is greater than g of x when x equals 4 and justify your answer. So, we are going to figure out what is g of 4 and what is f of 4. So, to find what g of 4 is, I'm just going to use the formula that they gave me and substitute 4 in for x. When I do that, I'm going to find that g of 4 equals 3. And I already know what f of 4 is because I did that on my graph and I looked at my table. F of 4 is 9. So, in this case, yes, f of 4 is greater than g of 4 since 9 is greater than 3. That is my justification. 30 wants me to determine algebraically, again, that word algebraically, the zeros of f of x. Now, normally I would say go ahead and use quadratic formula, But the quadratic formula only works if you have x squared. We have x cubed. So I'm going to have to factor. What I have to look at is first ask, is there going to be a GCF? And the answer is yes. Each of these terms can be divided nicely by 3x. So if I divide each of these terms by 3x, I'm going to be left with x squared plus 7x plus 12. Now this is not factored completely yet, so I'm going to bring down the 3x, and now I'm going to factor what was left inside the parentheses, because now I have a trinomial when x is 1. So what I need to figure out is what are factors of 12 that also add to 7. Those two numbers are going to be 4 and 3. Now in order to actually solve this, I have to set each factor equal to 0. And then I can solve. Now, when 3x equals 0, in order to get x alone, I must divide both sides by 3. So one answer is x equals 0. To get x alone here, I need to subtract 4. So my second answer is x equals negative 4. And my last answer, when I subtract 3, is x equals negative 3. Now normally we're used to finding only two answers, but because this is a cubic function with an exponent of 3, we now have the opportunity to see 3 answers. Number 31 has Santina is considering a vacation and has obtained high temperature data from the last 2 weeks between Miami and Los Angeles. Which location has the least variability in temperatures? Explain how you arrived at your answer. So if we compare the two, Miami versus LA, and we look at the highest and the lowest temperatures between each place, Miami has a high temperature of 87 and a low temperature of 60. So if we figure out the range of temperatures, and we go from 87 down to 60 and we subtract, we're going to have a range of 27 degrees. Looking at Los Angeles, the high temperature in this data set is 74, where the low temperature looks to be 61. So in Los Angeles, the temperature ranges from 74 down to 61, so the range in temperature is 13 degrees. So between these two, LA has the least variability because it has a smaller range of temperature. So you want to think of it in terms of variability, like how much is it changing? So since Los Angeles has a smaller range of numbers for their temperature, that's what you're going to have to choose. Number 32 says to solve the quadratic equation below for the exact values of x. So exact values meaning, like if it's a decimal that can be turned into a fraction, they want the fraction version of that answer. They want it to be exact. They don't want you to round or anything. So, in my opinion, the easiest way to solve this is to add 5 to both sides to isolate the x's, and I have 4x squared equals 80. Now, to get rid of the 4, I could divide both sides by 4. I'm left with x squared equals 20. And to get rid of the square, I could take the square root of both sides. And I would have an answer of x equals plus or minus the square root of 20. Now this is an exact answer. It doesn't say that I have to keep it in simplest radical form. I could, but I don't have to. If you're familiar with simplest radical form, you would figure out what perfect square goes into 20, and that would be 4, and 4 times 5 is 20. Square root of 4 is 2. So in simplest radical form, my answer could be plus or minus 2 radical 5. So whichever answer you choose is fine. But again, since they did not say, make sure your answer is in simplest radical form, they will accept x equals plus or minus the square root of 20. Number 33 says that Marilyn collects old dolls and she purchases a doll for $450. Research shows that the doll's value will increase by 2.5% each year. We're going to write an equation that determines the value of V of the doll T years after purchase. Okay, so when you see a percent and you see that it's increasing, your first instinct, hopefully, should be to remember this formula, this exponential growth formula, where y is what you're looking for, c is the initial value, so in this case, c is $450. R is the rate as a decimal. Now they told us the rate was 2.5%, so 2.5% as a decimal, if we divide that by 100, then our R value would be 0.025. T is time. They didn't tell us how many years, so they want us to use T for time. And instead of Y, they want us to use V for the value of the doll. And I know that this is increasing because it tells me, so that's why it has to be the addition. So my actual equation has to be V equals 450 in parentheses 1 plus 0.025 to the power of t. Now I'm going to use this formula in the next part because it says assuming the doll's rate of appreciation remains the same, so that's that R value of 2.5% or the 0.025 decimal, that's staying the same. It says will the doll's value be doubled in 20 years? Justify your reasoning. So what we need to do is use the formula that we just created, and instead of keeping it as t as the exponent, we're going to change that to 20. So when I type that in, I'm going to get a value of, I'm rounding, $737.38. Now, I need to make sure that this is being doubled, yes or no, and so if I double the original value of the doll by multiplying 450 by 2, I'm going to get $900. So since in 20 years the doll will be worth about $737.38, it's not going to be doubled by the original value because $900 is not the same as $737. So since I ran out of room, I wrote the explanation, these little squiggly bubbles. So to justify it, I just wrote that since $900 is not equal to $737.38, therefore no, the doll's value will not be doubled in 20 years. So you really want to make sure that you can justify your reasoning not only with the math, but with a statement at the end. Number 34 says that the data given in the table below shows some of the results of a study comparing the height of a certain breed of dog based upon its mass. We need to write the linear regression equation. Linear regression equation for these data where x is the mass, y is the height, and we're going to round all values to the nearest tenth. So when you see the words linear regression equation, hopefully your first thought is to type these values into your list in spreadsheets in the calculator. The mass they said was x, so we're going to type that into list A with a title, and the height is y, so we're going to type that into list B with a title. Then we're going to go through our calculator. We're going to have to hit menu, statistics, stat calculations, choice 3 for linear regression mx plus b. And when you do that, it will tell you what your slope is and what your y-intercept is. So this will always be the format, y equals whatever your m is, times x plus whatever your b is, and your calculator will tell you, we just have to round to the nearest tenth, that our slope is 1.9 and our y-intercept is 29.8. And that's all you have to do for the first part of this question. Then you're going to state the value of the correlation coefficient. Correlation coefficient is also found on the calculator on the same page, and what that means is to find the r value. So they tell us to round to the nearest tenth for the r value and then explain what it indicates. So if we look at our calculator, rounding to the nearest tenth, our r value is 0.3. Now, to explain what this indicates, well, that means that since r is close to 0, this is going to be a weak relationship between the height and mass of a certain breed of dog. So it's always good when you're explaining to refer back to the information that you're talking about. So since this table is referring to a certain breed of dog, and it's comparing their mass to their height, that's what you want to talk about when you do your explanation at the end. 35. Miranda received a movie gift card for $100 to her local theater. The matinee tickets cost $7.50 each. Evening tickets cost $12.50 each. If X represents the number of matinee tickets that she could purchase, Y represents the number of evening tickets that she could purchase, write an inequality that represents all the possible ways that Miranda could spend her gift card on movies at the theater. So, we don't need a let statement because they already told us this is what X represents, this is what Y represents. So that saves us some time. They told us it's an inequality, and since she has $100, we can't go past it. So it's got to be less than or equal to 100. Since matinee tickets cost $7.50 each, and X is the number of matinee tickets, then those two things have to go together. So $7.50 times X. We are going to add in the evening tickets, and since evening tickets are going to cost $12.50, and evening tickets represents Y, those two things have to go together. And all we have to do is represent this, and so that's all you have to do for the first part. Now, since we'll be graphing in the next part, we might as well take the time now to get Y alone. So anytime that you're graphing, you always want to get Y alone, and to do that, we will subtract both sides by 750x to start. When we do that, we have 1250y is less than or equal to negative 7.50x plus 100. Then when we divide everything by 12.5, we will end up with y is less than or equal to negative 3/5 x plus 8. And we're going to have to use that in the next part to graph. So, since our y-intercept is 8 and our slope is negative 3/5, we know that we only need to go as far as 8 on the y-axis, so we can definitely count by ones. And since they don't label anything as far as the numbers, they have labeled it in words, but we need to show what we're counting by. So even though I'm counting by ones for each block, I'm just going to label every 2 blocks just so it's not so messy. And then I can start plotting my points. So remember that we can't extend our line past the x and y axis, so we're not going to have any arrows because we can't go into the negative amount of tickets on either side. And since this is a less than or equal to inequality, it's going to be a solid line, and the shading will be below. So this is our solution set. We're going to want to label the line with our inequality, which is y is less than or equal to negative 3/5 x plus 8. And that's all we have to do for our graph. Now we're going to answer a question about it. So it says, what is the maximum number of matinee tickets? Now remember, matinee tickets are the X values. Miranda could purchase with her gift card. Explain your answer. Well, if we look at our graph and we look at how far our solution set goes in the X's, well, the farthest number that it goes, that's a whole number because we can't have part of a ticket, would be 13. So I am going to put my answer up here because I don't have room to put it down there, but we're going to say that 13 is the maximum number of matinee tickets, and our explanation we could do with a check. So I'm looking at the x-axis, which means my y value is 0. So if y is 0 and I do a check by plugging a y value of 0, and I have 0 is less than or equal to negative 3/5 x plus 8, and I solve this, well, I would have to subtract 8 from both sides. So I've got negative 8 is less than or equal to negative 3/5 x. And if I multiply both sides by negative 5/3, I'm going to have to flip the inequality around because I multiplied both sides by a negative. And I have 13.3, repeating, is greater than or equal to x. And if it's easier to see it sometimes when x is on the left, so if I move x to the left, I have to flip the inequality again. So x must be less than or equal to 13.3. Well, if x has to be less than or equal to 13.3, then the first whole number is 13. So we're going to have 13 matinee tickets, and I can show that with my equation. Question 36. One spring day, Elroy noted the time of day and temperature in degrees Fahrenheit. His findings are stated below. At 6 a.m., the temperature was 50 degrees, and for the next 4 hours, the temperature rose 3 degrees per hour. The next 6 hours, it rose 2 degrees per hour. The temperature then stayed steady until 6 p.m. For the next 2 hours, the temperature dropped 1 degree per hour. The temperature then dropped steadily until the temperature was 56 degrees at midnight. On the set of axes below, graph Elroy's data. So what I chose to do was I made a table and then I plotted my points. Now you don't have to do a table, I just found it helpful. Okay, so here's the setup of my table. It might not make sense at first, but my x's are in time, but it's time away from 6 a.m. So 6 a.m. is time 0, and then it goes all the way down to 18, because 18 hours from 6 a.m. is midnight, and that's where it's supposed to stop. So the first thing it says is that at 6 a.m. the temperature was 50. So I can start that on my table, and it says for the next 4 hours the temperature rose 3 degrees per hour. So that means 53, 56, 59, 62. And again, that 4 in time means 4 hours from 6 a.m., so now we're at 10 a.m. Then it says the next 6 hours it rose 2 degrees per hour, so starting at 11 a.m., it's going to go up 2 degrees, so that's 64, 66, 68, 70, 72, and by the 10th hour, so by 4 p.m., it's going to be 74. It's hard to read that. Okay, so that's the first two things checked off. The temperature then stayed steady until 6 p.m., so that means that it's going to stay at 74 degrees. So that's the third thing. For the next 2 hours, the temperature dropped 1 degree per hour, so that means that it's going to go down 73, 72, 2. So that's the next 2 hours. So that's checking off the fourth one. And then it says the temperature dropped steadily until the temperature was 56 degrees at midnight. So it doesn't tell me what I'm dropping by. All I know is that by midnight I am at 56 degrees. So let's see here. If at hour 15, hour 16, hour 17, hour 18, I have to figure out what am I going down by to get to 56. And if I do the math, I should be dropping 4 degrees each time, because from 72, if I drop 4 degrees, I'm at 68. I'm going to go to 64, 60, and then down to 56. Okay, so now I just have to plot the points. So this is roughly what the graph should look like. There are no arrows because this is just the temperatures that Elroy actually plotted and figured out. So he didn't go on after midnight or start before 6 a.m. So it says state the entire time interval for which the temperature was increasing. Well, it's increasing from 6 a.m. until 4 p.m. where T represents the time in hours. And determine the average rate of change. Well, that means slope in degrees per hour from 6 p.m. to midnight. Okay. Well, if we consider these ordered pairs, at 6 p.m. we have 74 degrees, and I called 6 p.m. value 12. So that would be 12 comma 74. And then midnight I called point 18. So that's 18 comma 56 degrees. And so if I use the slope formula and I subtract the y values, so 74 minus 56 over 12 minus 18, I should get 18 over negative 6, which simplifies to negative 3, and they want it in degrees per hour, so that's what I will state after it. This is negative 3 degrees per hour. And that's my final answer. All right, 37. A recreation center ordered a total of 15 tricycles and bicycles from a sporting goods store. So that's important. The number of wheels for all the tricycles and bicycles totaled 38. Write a linear system of equations that models the scenario where T represents the number of tricycles and B represents the number of bicycles. So again, they told us what letters to use, so we don't need to come up with any let statements. We can just start with our equations. So if T and B are the amount of bicycles, there's a total of 15, then when we add them together, they're going to equal 15. So that's one of our equations. The second one deals with wheels. So a bicycle has 2 wheels, a tricycle has 3. So 3 wheels for a tricycle plus 2 wheels for a bicycle will equal a total of 38 wheels. Now in the next part we're going to have to graph. And it's not x and y, it's t and b. But according to our graph and how they labeled it, B is considered the y-axis. So we need to get B alone. So in order to get B alone, if we subtract T in the first equation, we'll have B equals negative T plus 15. So that's one of the equations that we'll have to graph. The second equation, we need to get b alone, so we're going to subtract 3t from both sides. We have 2b equals negative 3t plus 38, and then we're going to divide every term by 2. So when b is alone, we have b equals negative 3/2 t plus 19. And here is the second equation that we'll have to graph in the next step. So we're going to make sure that we start at 19 for one of our lines and go down 3/2 units, and the other graph starts at 15 on the y-axis and goes down 1/1. So we'll plot those points now. So here are my two graphs. I will try to label them. So my red line was b equals negative t plus 15, and my blue line was b equals negative 3/2 t plus 19. It's hard to tell, but my graphs are supposed to intersect at the point 8, 7. So this is where they should have intersected. So, based on our graph of the scenario, could the rec center have ordered 10 tricycles? Explain your reasoning. So tricycles was t, which back on our graph was the x-axis. Then, based on our graph, no, the rec center could not have ordered 10 tricycles since the solution to our system of equations is the point 8, 7, which represents 8 tricycles, not 10. And that's all we have to do for our last question.